Okay, so yes, at the so regarding the final exam, which will be 1 week from today, I still have to write it, okay? But the questions that I write for the final exam will be based on the conceptual questions that appear at the end of each of these chapters, right? And so, some of them are difficult to put into kind of exam form, but like, obviously not this exact question, but something like this, right? Where it says, let's suppose you use least squares model and you get beta 0 hat is 50, beta 1 hat is 20, beta 2 hat is this, and beta 3, beta 4, and beta 5, right? And it talks about 1 being GPA, 2 being IQ, 3 is gender, 4 is the interaction between GPA and IQ, and 5 is the interaction between GPA and gender, and it's going to ask, which of these is correct. And I think a question like this is a fair question to put on the exam to kind of, check your conceptual understanding of, what the, whether a positive or negative coefficient here and what that means regarding different variables and stuff. Okay, and so as far as studying and preparing for the final, I guess your study guide would be to look at the conceptual questions that appear at the end of each chapter. Okay, and I feel like if you can confidently answer any of these conceptual questions, then we've got a good grasp on the material covered in the course. Okay, because as far as the applied stuff, that's like almost impossible to test in a pen and paper exam, and plus all of that stuff changes as time goes on because new packages get developed and things like that. But the conceptual stuff generally remains the same. So so here's here's an example where you kind of have to plug in some numbers. So you'll want a calculator, but it says, suppose we collect data for a group of students in a stats class with the variables x1 is our study, x2 is undergrad GPA, and y is they receive an A, yes or no. Okay, and fit a logistic regression and produce. We fit a logistic regression and we produce these estimates. Beta 0 is this, beta 1 is this, and beta 2 hat is this. And then, what happens if you plug in 40 hours and a GPA of 3.5, right? And then you'll need a calculator. Yes. Okay. I probably won't put in too many of these things, but you should know enough to compute something like this, right? So yeah, I'll happily review any and as many questions as you want on Monday. Okay, obviously we can't go through all the conceptual questions that are listed in the book in a 2-hour session, but so between now and Monday, look through those, see what you can answer, and the ones you get stuck on or you have questions about, bring them to class on Monday, and I'll happily go over them. Okay, or I might say like, don't worry about this topic. Okay. Okay, is that all right regarding, I guess, the one test that we'll have, the final exam? Okay, yes?
But we won't have any mathematical proof question.
Mathematical proof?
On the chapter 3, the conceptual question,
there's one where you have to derive stuff? I don't. let me work on writing the exam this weekend, okay? And then I'll come back, and then on Monday I'll have a better idea of like what I've included and what I haven't included. I probably am leaning towards not putting in any kind of derivations in there, just because they're really hard to grade, and I don't enjoy grading derivation type work or proof type work. So I probably won't include that in there, but I don't know, maybe as I'm writing it, maybe I'll say like, oh, this is actually a good topic that I should include, but we'll see, okay? I'll have a better idea on Monday what the exam looks like, okay? But probably it'll be like 1 or 2 questions from each chapter, okay? Well, yeah. 2 hours, 20 questions. I guess, and then, I guess if it's a multiple choice, it might be like if I do multiple choice questions from each chapter, it'll be probably more than 2, right? It'll probably be a few more. So depending on how these questions are written, it'll probably end up being a little bit of a mix of stuff. Again, I still haven't written anything, so I have to do that. Okay, any other questions? Okay, and we're all comfortable with what's expected for the report for the final project? Just a few pages kind of describing your model, how you came about it, and then and all of that. Yes? You need to include the code. The code doesn't have to be included in the report, but the code does need to be submitted, okay? Because I will verify that the code does indeed produce the predictions. Okay. All right. Well, I thought. Again, if you have any questions about anything from the textbook, I'm happy to answer. I thought today we could just do something a little bit different, and just kind of take a look at stuff that's, I guess, tangentially related, in that when we so, all of the methods covered in our textbook, all the data is coming in already numerically formatted, right? So everything's kind of in this clean format where each observation is a row and each column is generally a numeric variable. And I think in our modern age, we have lots of other data sources that that are not as nicely formatted, okay? Now, many of these applications and methods can still be applied, but we need also a whole new set of methods that will turn non-numeric data into numeric data, right? So probably the 2 biggest use cases, or not use cases, but the 2 biggest kind of jobs that exist out there is one is dealing with image and video data, okay? And we have to have a way to deal with image and video data, which is already numeric because everything comes in as the kind of the color intensity of red, color intensity of green, and color intensity of blue, okay? All of these, what you're seeing here is the result of red, green, and blue being projected onto the screen. And so it's already numeric, but it's incredibly high dimensional, right? This is 1080 by 1920, so that's like almost 2 million values, an array of 2 million values, and you multiply that by 3 channels, and this one image that's appearing here is around 6 million different values, and right? 1080 by 1920 is on the order of 2 million times three channels. Yeah, 6 million. And if you've got a video, you've got around 30 frames per second. So 1 second of video is going to be 30 times 6 million, and you have 180 million values. And so you have a lot of ways to deal with super high dimensional these huge arrays and stuff, and that's kind of dealing with images and downsampling and all sorts of stuff for that. And then the other thing, which is what we're going to take a look at today, is dealing with text data. Okay, and so we kind of live in the age of I don't know what you would call this, the age of social media and stuff that's flying around on the internet. And so Twitter is a rich source of data. It's also a rich source of nonsense and crazy, but there's a lot of text flying through there, and and there's news articles and all sorts of stuff, and it's represented with words, right? With not numbers. And I'm not a linguistics major, but just the whole idea of communicating ideas through speech and words is totally amazing if you stop and think about it, right? That it's like your brain explodes if you just think like, this set of sounds coming out of my mouth is telling you, like, communicating ideas about analyzing data, and then and those sounds are represented by these squiggly characters that appear on the screen. And but anyway, all of this comes in, and we want to be able to get our statistical learning systems to extract data. So so it's hard that we just have to be able to turn the text into basically a numeric form, okay? And so in R, I would say there's a few major systems that that exist, and one is called package TM in R, and this stands for text mining. TM, package TM. But I thought today we would look at something called tidy text. Okay, I'm assuming everyone here took 102A and is familiar with dplyr. Is that not true for anybody? Has anyone here not taken 102A? You have not taken 102A. Okay. Anyone else? Okay, you also have not taken 102A. All right. Have you ever used dplyr? Okay, so you've used dplyr. Anyone here not ever used dplyr? Okay. So, all right, so at least we've all used dplyr, and do we like dplyr? Okay, because I love dplyr. I love the tidyverse and Hadley Wickham's work, and all that he's done to kind of make data analysis kind of flow in a sense that I think is works well. So anyway, I want to reference you guys to this website called Tidy Text Mining, and it's a website and a textbook that uses the kind of the tidy structure in dplyr as kind of the main elements of analyzing text data. Okay, and so it does deviate a little bit from certain traditional methods of like the TF-IDF and things like that. You can still use it to make TF-IDF matrices and stuff, and I'll get into that in a moment. But tidy text mining, you can just go to tidytextmining.com, and this is also so text mining with R. and it says a tidy approach, and this is the textbook, and you can buy this book on Amazon. You don't have to. It's around $30. It's highly rated, and you can also access it for free. Well, okay, so first of all, this website pretty much is the entire textbook, okay? But if you want like the official version, you can go to proquest.safaribooks online while you are connected to the UCLA network. While you guys are here as UCLA students, you should really take advantage of the UCLA library. It's unbeatable, okay? As far as research materials and reference materials go, it's really hard to find like a better library, like what, the Library of Congress maybe, but the UCLA library is really really good, and the digital access collection is huge as well. You know, especially for us in like the STEM areas. Anyway, so ProQuest.SafariBooks Online is something that the university pays quite a bit of money to access using your tuition dollars, so you might as well take advantage of it because you are paying for it via your tuition. So just like state parks and national parks, you should visit those things too, right? Even your tax dollars go there too. Okay, so anyway, you can always look up text mining here, and here it is, okay? And you could read it in your browser. That's the only thing. You have to read it in your browser. They don't have a PDF version of it, okay? So to kind of make it difficult to copy and distribute, okay? But I would say just this website might even be preferable, because from the website you can actually copy and paste the code here. And in general, I recommend not copying and pasting code, but it can be done for this website. Okay, so anyway, this is it's a great resource. Okay, so I thought I would just kind of walk through like maybe the first chapter or two of Tidy Text, where we just do some basic text, dealing with text here. Okay, and so the idea of the tidy text format. Okay, so if you want to use, if you're going to follow this book, it uses the tidy data scheme, which says each variable is a column, each observation is a row, and each type of observation is a different table. So so here, when we say each observation is a row, okay, we are using something called one token per row. Okay, and token is a fancy word. Most often a token is a word. Okay, so most often you will take like a sentence and you will split that up into words, and each word will be a token, and it will get its own row. But you know, you're not required to set each token to be a single word. It can be an n-gram. An n-gram is 2 words at a time. Okay, so so if this were your sentence using tidy data principles, your n-gram, if it was a 2-gram, a bigram, one of them would be using tidy, and the next one would be tidy data, and the next one would be data principles. Okay, so that would be bigrams. Okay, and then you can have trigrams, where you have take 3 words at a time or something like that. But most often we're using just single words or 1 grams. Okay, but you can also, if you can take the entire sentence to be a token, or an entire paragraph to be a token. It gets quite difficult to deal with paragraph-sized tokens. So so generally, the most common is using 1 word for a token. But So usually, so when you hear one token per row, probably your first thought will be one word per row. But again, you can be dealing with n-grams where you're using a few words at a time. Okay, and then and once you have it here in this kind of one token per row, then you can use all of the tidyverse packages, particularly dplyr and tidyr and ggplot and things like that. Okay. It talks about other stuff. Okay, so the function that will take text that generally, the way we might see it, to turn it into tokens will be this function called unnest tokens. Okay, and so it comes in, and so you might have like a little poem. So this is a poem written by Emily Dickinson. And it, it rose, because I could not stop for death, he kindly stopped for me. The carriage held but just ourselves and immortality, right? Emily, she was a troubled individual, right? So anyway, did you guys take literature classes and read Emily Dickinson stuff? Okay, well, you guys missed out. I get, a lot of artists have their struggles with internal struggles, right? And it's expressed in their art, and perhaps that's what makes their artwork compelling. But yeah, anyway, okay. So anyway, so if you just read something in like this is just a vector, and each item in the vector is just string, right? Okay, so if we wanted to use this unnest tokens function, okay, if we just said, well, how does unnest tokens work? Okay, you got to provide it a data frame, okay, or in the tidyverse we use tibbles, and you guys are okay with tibbles. Tibbles are basically just data frames, but with a few extra things so they are formatted nicely, okay? And they don't automatically convert strings into factors and stuff like that, okay? So anyway, so we created Tibble out of this, okay? And all we do is we just say, let the text be the text here, and then we'll create a column called line, and so this is what our Tibble looks like, okay? Lines 1, 2, 3, 4, and here's the text. And as far as unnest tokens go, okay, we are going to feed that into, we're going to take our text df Tibble and feed it into the unnest tokens, okay, and as far as outputs go, we want the word and the text. And so if we do this, okay, then the output is it takes each the line input, okay, and it took it's unnesting the tokens in the text column, okay, and it creates a word column of it, okay? And you can see that this unnest token already does certain things for us, which is it lowercases everything, okay? And it gets rid of anything that's not a word, okay? So now the poem is written this way: because I could not stop for death, he kindly stopped for me, the carriage held but just ourselves and immortality, okay? Yes?
Does unnest tokens just like by default look for white space, or could you specify like?
Yeah, I mean, so you can specify different things. So by default, the token is going to be words, okay? But you can do other things. So you can have it do characters and n-grams and different kinds of stuff. But yeah, by default, it's going to look kind of for spaces, like commas and things. So I think, let me see. Like if I put in a comma here and a period here, okay, it should also, it's going to strip all that punctuation, okay? Let me just see. If I didn't put the space there, I'm not sure what's going to happen here, okay? I dash, let's see. Okay, it's still, it still parses it there, okay? So I guess it's looking for basically non-word characters to kind of parse it. I haven't like played around with it a ton to see like what breaks it, okay? But you know, this is a package that hasn't been around for like too long, but I feel like it's been fully vetted because I think there's a growing user base of it, and so probably a lot of these little quirks and things have been, some of the kinks have been worked out. So okay, so there it tokenizes this thing, and so now we can start applying you know, analysis things. Okay, so anyway, so we've got that there. Okay, so here are some. This is oops. Okay, so the next thing that we're going to do is we're going to take a look at, I guess, a bigger set of text, okay? And so because it's available in the public domain, we can take all of the text of Jane Austen's books, okay? So has anyone read any of Jane Austen's books? This is the wrong class to ask the questions, right? Like, Pride and Prejudice? Anyone at least seen the movie Pride and Prejudice? Okay, all right. So at least we have like a starting thing, right? Like nobody reads literature for fun? A little bit? Sci-fi? Okay, okay. All right, okay. Well, I guess we do look at H.G. Wells because his stuff's in the public domain, okay? So we're only like as far as the stuff in the textbook shows up, right? Just public domain stuff. Okay, but anyway, so we'll bring in Jane Austen, okay? And all of that data, so you have to load the library Jane Austen R, okay? And if you bring in, if you load up Austen's books, okay? The Jane Austen books, okay. All right, this is the, let's look at the first 15, okay. For Sense and Sensibility, the first 15 things we get are, it has the book Sense and Sensibility, and then it starts off with, you know, the family of Dashwood had long been settled in Sussex, something, 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 right? Okay, let me bring this here. So we have 6 unique books: Sense and Sensibility, Pride and Prejudice, Mansfield Park, Emma, Northanger Abbey, and Persuasion. Northanger? I don't know what this is. Okay. Okay, and then so if I were to just extract like Pride and Prejudice or something like this, okay, I think this is a very famous line, or maybe it's not. The first line of Pride and Prejudice: "It is a truth universally acknowledged that a single man in possession of a good fortune must be in want of a wife," is, I mean, you know, this was the sentiment of the time, perhaps perhaps things are different today, but this was the this was that, and that was Jane Austen's the thing. Okay, so anyway, we are going to do some tidy text here. Okay, so let's go line by line through what this thing does. Okay, so Austen Books again is just the this data frame. Okay, where each line of text is a line of text, and there's also a second column for the book from which this came, because this is all the lines from all 6 books that she has written, right? So we are going to group it by the book, okay? And things will start. And what does this do? Okay, so mutate says the line number is going to equal the row number, okay? So what does that do? So we're creating a column called line number, and it's going to be the row number, but because we've done group by, it's going to reset every time it reaches a new book, right? So like if I did, currently if I did a tale of Austen Books, okay? Okay, so the very last, I don't know if this is a spoiler for Persuasion, this is the last word is finished, but this is going to be I don't know how many, 73,412, right? So that would be line 73,412, but because we've done group by book, the row number resets every time we reach a new book, okay? What does this do? Chapter equals cumulative sum, string detect within the text, this regex of chapter // divxlc, ignore case. What does that mean? Okay, so what is this regex? You guys remember, you guys learned regular expressions, right? Okay, so this means what? Start of the line, okay? So the line has to start with chapter, okay? And then // d means what? A number, right? A digit, okay? So does it start with chapter 1 or chapter 2 or something like that, okay? Or, and why do we throw in IVXLC?
Is that like the Roman?
For like Roman numerals, because sometimes we have like chapter I and chapter II and chapter III, right? Like in Roman numerals, okay? So this is to kind of detect, does a line start with, say, something like this, chapter 1 or something, okay? And then we ignore the case, okay? And so this is going to detect it, okay? It has to start with chapter. So I guess it's possible this gets confused if like one of the lines starts with like a chapter 2, but it's not actually a real chapter beginning. I don't know. I'm just trying to think of a sentence where I was starting a new chapter in my life, and then it would start with chapter I. I don't know if it would, okay, but anyway. So we tell it to do that, and cumulative sum will just, every time it detects that this pattern where it starts with chapter, it's going to increment to chapter 1, chapter 2, chapter 3, and something like that, okay? And then we feed it into ungroup, okay? And so here is, this is where, this is kind of the results of that. Let me do print original books, n equals, let's do like 100, whoops. Okay, and so here, what we see, okay, so it starts off here, and we get line number 1, 2, and so this is the first 100 lines, and we can see that the chapter increments right here as soon as it says chapter 1, and then, let's see. Okay, so after 1,000 lines, so we can see that it increments the chapter from chapter 6 to chapter 7 when it detects this line has started with chapter, right? Okay, so now this is what we have. Okay, so so we've basically just taken all of Jane Austen's books and have given them line numbers where how many lines is this book? Maybe I should go to like 15,000. Okay, so finally we're in Pride and Prejudice. Okay, and so we can see that it resets, that the line number also resets with each new so Sense and Sensibility is over 12,000. Let's go over to 13,000. Okay, and then Pride and Prejudice, these reset, okay? So because we did group by book, the line number and chapter numbers reset with each new book, okay? All right, so so we did that, and okay, and then so now what we're going to do is we are going to take each line and then parse it so that we're going to get it tokenized into words, right? So currently there is about 73,000 lines of text, okay, in this original book's data frame. And what we are now going to do is we're going to take all of that stuff and we are going to unnest the tokens, okay? So we're going to take original books and we're going to do what we did earlier, where we're going to take that column of text, okay, and we're going to take this column text and then unnest them into words, okay? So we'll go ahead and do this, and it takes just a moment to run, okay? So that was really quick. It ran through all 73,000 lines there, and now we have tidy books, okay? And so this gets rid of all of the blank space, and so now it starts off Sense and Sensibility by Jane Austen, 1811, Chapter 1, and then we can ask print n equals the first 100 words. Oh geez, what did I do? Okay. And so now it's run here, right? Sense and Sensibility. Okay, Chapter 1, the family of Dashwood had long been settled in Sussex. Okay, so now we can do some stuff where we're dealing with these word counts, right? Okay, the next thing that we are going to do, all right, is we're going to take in stop words, okay? So what are stop words? So usually when you do text analysis, you want to get rid of words that just appear a little bit too often. Now you can, there's different things, but basically, you know, the word a doesn't really add much meaning, okay? So this stop words are often like prepositions, like when we're talking about so articles like a and the, and then prepositions like of, about, over, and stuff like that, okay? And so, you know, we can look at like the first 100 or something. Oops. Nah, I have to do. Okay, so these are all counted as stop words, okay? And according to different lexicons, and so it throws in about 1,000 of these things, okay? All right, so what does anti-join do? Do you guys know? So it's like the opposite. So it's like a SQL thing where you're taking this and you're joining them, but it's doing an anti-join. And so basically, the anti-join is things that are not in common, right? So if you have ABC over here and ACD in this thing, okay, the anti-join is going to find matches and remove them, and it's going to return B and D, okay? Whereas like the full join will give you the union ABCD, and the inner join will just give you what's common AC. So the anti-join is basically the opposite of an intersection, okay? So if you think of the Venn diagram, the anti-join is the part without the middle, I don't know, overlapping section. Okay, so that's what the anti-join is. Okay, so when we do, so tidy books right now is a list of all of the individual words, right? And we're going to anti-join them with the stop words, and so this will basically remove all of the stop words by doing an anti-join. Okay. Okay. And then so now we can, now that we've updated all of our things, we've removed the stop words, okay? We can do something like just the most basic analysis, and we can just count how many times the words have appeared, right? Okay, and so the most common non-stop word is miss. Maybe that should be maybe that should be a stop word. I don't know. Okay. Time, Fanny, dear, lady, sir, day, Emma, sister, house. Okay. So this is almost like a reflection of the era in which this book was written, because probably if we were doing text analysis back in the 1800s, a lot of these things would be stop words, right? Things like, because they always addressed people using these titles, right? They would always like Miss, Mr. Darcy and stuff like that, rather than just calling them by their first name, right? Mr. Bennett, Mr. Darcy, and things like that, rather than saying Liz and Betty or whatever. Okay, so we've got lady and sir and things like that. Okay, Emma obviously appears a lot because there's a book called Emma and things like that. So I guess her name shows up 787 times, okay? And so we get this, and you can create a plot of all of those things. I'm gonna go ahead and skip this because I don't think this is all that exciting. All right. Here is another thing where we can look at more text from the Gutenberg package. Okay, so there's Project Gutenberg, which just tries to accumulate a bunch of public domain text. Okay, and so here, if you load up Library Gutenberg, you can pull out the text for H.G. Wells, his text, his books that he's written. Okay, so I think The Time Machine, War of the Worlds, The Invisible Man, and The Island of Dr. Moreau, right? And we can do something very similar to clean up H.G. Wells text. So we're going to do basically the exact same thing. Unnest the tokens, do an anti-join, getting rid of the stop words, okay? And we can do a count on H.G. Wells stuff, okay? And so so as far as his books go, the word time shows up quite a bit, which makes sense because he wrote a book called The Time Machine. And then there's people and door and heard and black and stood and white. Okay, and so H.G. Wells books, I don't know if you've read any of them, they're not so much about character development. Like, does the Invisible Man even have a name? I don't know. I think he's just okay. So it's much more like Jane Austen's. It's all about these interpersonal relations, and H.G. Wells is much more. It's less about that. Okay, it's science fiction stuff, right? Okay, and then there's works by the Bronte sisters. And so you have things like Jane Eyre, Wuthering Heights, and things like that. Okay, and you can download that. And so these appear here. And so this is just like a very basic analysis to see, is the work of Jane Austen, is it more similar to the work of H.G. Wells or more similar to the work of Charlotte and Emily Bronte? And I think we know the answer to this already, but we can do a little bit of work here, right? And so if we look at the word counts of the works by the Bronte sisters, we get time, miss, day, hands, eyes, night, and heart. Okay, so here they do just a quick analysis here. All right, and so this is a whole bunch of I don't know if we want to go through this line by line. Okay, but basically we're going to combine all the texts together. Okay, but we're adding a column for whether it was written by the Bronte sisters, H.G. Wells, or Jane Austen. Okay, so we can do that, and so it's basically all of these things. We've got, every single word that appears in these things, so 23,000 words, unique words and stuff that appear in these novels along with their counts. And I'm sorry, this is not the counts, the Tidy Bronte. So if we take this is actually all of the individual words, so 251,000 words. And if we do Tidy H.G. Wells, so we're gonna, if we bind all of this together, before I do anything else, this is gonna be on the order of like 1 million rows, okay? Or 500, okay? Oh yeah, and then because there's nothing here for book line number and chapter, because we did that earlier for Jane Austen's things, but it doesn't matter, okay? And so here, we're going to take the words and we're going to take each word in case did something happen? Okay, and then and we just kind of do a little bit of cleanup, because sometimes I guess these underscores get trapped in there. So anyway, so this cleans it up, gets rid of the underscores. We can then apply a count, okay, based on each author, okay. So the count takes a little bit of time, okay? And so we can say how many times each of these things happened for each author, and then we will do a group by, okay? So unfortunately, we probably should have done the string extract and then done the cleanup a little bit there, okay? So we do a group by, and then here we do and then here we're asking the proportion, okay? So how many times each word appears, and so we do the proportion, and then we sort them by kind of the counts here, all right? So let me just show what this does. Okay, so now we are So we get all of these things, and then we're going to spread them by author and proportion, and then we'll gather them back up, okay? So finally, so we do this, the spread makes it really wide, but then the gather takes it back. Oh. Okay, and so we can take a look at the head of this, all right, and we're looking at each you know, Jane, the word, you know, how frequently a word appeared for Jane Austen, and compare it to the proportion that appeared in other, and for the other authors. Okay, so we're just taking each word, and so like in Jane Austen's work, the word abandoned appeared with this proportion, you know, a very small proportion. And how does it appear in the Bronte sisters' work with a slightly different proportion, actually much greater? Okay, and so so then we can plot this. All right, so this is a I don't feel like copying all of this, but this produces a plot where you can compare kind of the proportion of how frequently a word appeared in Jane Austen's books and how frequently it appeared in H.G. Wells' books or the Bronte sisters' books, right? And so something like for Jane Austen, the word miss appears almost 1% of the time, okay? And this is a log scale, by the way, all right, if you look at this. And for H.G. Wells, the word miss appears only 0.01%, right? So almost 1 out of every 100 words in Jane Austen's book is the word miss, and it's only about 1 in every 10,000 words for H.G. Wells, okay? Or something like that, right? Other things that kind of stick out, you know, Elizabeth appears very frequently and never appears in the Bronte sisters, which is totally not a weird thing because in Jane Austen, like one of the main characters' names is Elizabeth, so obviously it's going to appear a lot. And apparently in neither of the Bronte sisters' books was probably anyone named Elizabeth. Okay, so that hardly shows up, right? Okay. Whereas over here in H.G. Wells, the word beast appears very frequently, okay, but it doesn't appear much in Jane Austen's work, okay? So anyway, this is just kind of an interesting thing. We can do some kind of analysis on the correlation analysis, and we find that Jane Austen and the Bronte sisters, as far as their word pairing, there's a correlation of around 0.76 as far as the frequency values, and then the correlation between Jane Austen and H.G. Wells is only about 0.42. So as far as which words they use, there's much more overlap between Jane Austen and the Bronte sisters' work, which is, I think, what we would have expected than there is between Jane Austen and H.G. Wells' work there. Okay, why don't we take a short break here, and then and we can just look at a couple other things regarding some text analysis stuff. Okay, so we'll say I don't know, five minutes or so. Okay, we'll continue on. I guess maybe one of the first things we can do with text data is sentiment analysis. Okay, and so sentiment analysis is just basically taking a look at the words that appear in a sentence and trying to decide if this sentence has a positive sentiment or negative sentiment. You know, was this written by someone who was happy or excited or something, and or is this someone who's angry? and it's kind of like on Facebook, you have different sentiments that you can attach to a status. You can give it a thumbs up, you can give it a haha or an angry or a sad face or things like that. And people are saying Facebook is using this to gather data to improve their machine learning algorithms, and I'm sure they are. But anyway, kind of the idea here is that we are going to take our text, the words, and we're going to look up the words in a sentiment lexicon. And the sentiment lexicon is going to have entries, things like, for the simplest of sentiments, it's either going to be positive or negative sentiment. And so words like good and excellent and happy will all have positive sentiments, and words like bad and angry and hate will all have negative sentiments, okay? And so we are going to look those up, and then based on the sentiments that we find, we'll kind of summarize it and produce our visualizations or whatnot with it, okay? And so in the library tidy text, there is already a built-in data set called sentiments, okay? And it's going to have things like abnormal has a negative sentiment, and abolish and abominable and abominably, and these are all kinds of I guess there's 6,000 words here. Let me just do let's just take a look at some of these things, right? So these are the first 100 words like adaptable, I guess have a positive sentiment, admirable, and adorable, those are positive, and things like addicted has a negative sentiment or something like that, okay? Although, I see advertisements like for video games advertising as like super addictive, as if this were a positive thing. But that's, in my mind, that's not a good, we shouldn't be advertising addicting games, right? Like, if a game is going to be addicting, you should stay away, right? That's not going to make you happy. Okay, so there's apparently a few different lexicons, a few different things, the AFIN, the Bing, and the NRC, that give different sentiment scores. So the AFIN rates things between -5 and +5, and so the word abhor has it has a sentiment of -3, which is stronger than something like abandon, okay? Whereas the Bing lexicon just has positive and negative, and the NRC has different sentiments, like abandon comes with the sentiments fear, negative, and sadness, and abandoned comes also with anger or something like that, right? Abandon, so and so these are all created, and so anyway, one disadvantage of these sentiment things is that we don't get word contexts. So if the there is words like no and not, so not happy will definitely change the sentiment of the sentence. But when you analyze just if your token is just one word at a time, you don't have the relationship between no and not with happy or sad or something like that, right? Like not sad will suddenly have a positive sentiment, and not happy will have a negative sentiment. And so that gets lost. That gets lost when you do one word sentiment analysis. And so that's just something to be aware of. But overall, assuming our sentences are generally shorter and things like that, they can still be useful. It maybe not as useful as we wish at just this simple analysis, right? Okay, so anyway, this is the code that we run. Okay, so when we can take all of Jane Austen's books and we're going to kind of do the same thing that we did, where we unnest the tokens and have the line numbers and the chapters and things like that. And then we are going to use dplyer's filter, and we're going to find all of the words that are associated with joy. Okay, so I'll go ahead and I'll just run this stuff. I think this is already in R as it is. Go ahead and we'll run that. Okay, and so let's find all the words associated with joy. Oops. Is it Loughran? Let's see. It looks like the thing has changed. I'm having, why am I having trouble here? Library, tidy text, get sentiments. No package called text data. All right, maybe I have to install a package. You want to download? Yes. Oops. Well. Enter. Uh-oh. Maybe this doesn't work anymore. Okay, this doesn't work anymore. We don't have the NRC lexicon is no longer available. This is okay. Well, that's a bummer. Okay, well we have 344 things, but that's okay. But so we can still, do something similar and find kind of, as far as the book Emma goes, we can do an inner join, so just the intersection of kind of these positive sentiment words. Unfortunately, this lexicon is no longer available, so you'll have to kind of modify the code. But the positive sentiment filter words, and we can find which of these words appear most frequently in the text here. Okay, so here we get you know, good, great, better, happy, and pleasure, and so our results are slightly different here, but we find that indeed good appears quite frequently. Okay, so these are all the kind of positive sentiment words, and different. We can also just kind of see, do a comparison between you know, the positive versus negative things. Okay, and so here they just kind of arbitrarily said, you know, use about 80 lines at a time, and within each chunk of text, is there an overall positive versus negative sentiment? In this chunk of text, is there more positive words or negative words? In this chunk of text, is there more positive words or negative words? And one might expect that in a novel that there might be a shift from, you know, in the beginning there, you know, I don't know, positive or negative words, and depending on the flow of the story, okay, you know, if you think of how a story is written, you know, you often set up a conflict with the characters, and it takes a while, and towards the end you hope that the conflict is resolved, right? So, you know, we can try doing something like this to kind of just see how the scores go, right? So here for the book Sense and Sensibility, we can see if there's this is kind of the plot of the different sentiment scores. And so in Pride and Prejudice, you know, this is again just very loose, but you know, throughout the story, mostly positive, a few negative sections, and then there's a section where there's quite a bit of negative sentiment, and here there's quite a bit of negative sentiment, and again towards the end maybe we're back to positive. Mansfield Park or something, I don't know, it fluctuates, but this is just kind of a plot of the positive versus negative sentiment words to kind of just see if there is indeed a narrative structure where somebody talks about happy things in the beginning, setting up our fairy tale land or whatever it is, and then there's conflict in the middle of their story. Okay, this is just a loose analysis, and again, all it's doing is it's just looking at positive words and doing a count of the positive words versus doing the count of the negative words. Okay. And again, so this is doing a quick comparison between some of the different dictionaries. Okay, and so if we look at the words that are associated with positive versus negative sentiments for Affin versus Bing, we can see that there's quite a bit of overlap here, and then the NRC appears quite different from the others. And in fact, the NRC lexicon is not available today anymore. You have something different. Okay, but there's quite a bit of these appear quite similar, but you know there are some distinctions, and this all comes down to, you know, is the word I don't know, choice, is that a positive or negative sentiment words, and maybe it gets classified differently according to the lexicons. Okay, so this is sentiment analysis. This is kind of one of the most basic tasks that people do when you start doing word analysis, and it's just taking a look at the words that are available and looking at, you know, is one author or is one work of art, one work of text more likely to have certain positively charged words or negatively charged words, right? And so this is often used on different tweets and stuff, and so you can see, you know, different authors on Twitter. Their tweets are analyzed, and we see that some people are more likely to have positive versus negative sentiment tweets. Tweets are very difficult because there's also a lot of non-standard English words that appear in a tweet, and there's also a lot of sarcasm, which is difficult for machines, not to mention difficult for a lot of people to detect as well. So that's a whole other thing. When we get computers to understand sarcasm, that, I don't know, maybe we have to be afraid that day. But it seems we're a ways off from understanding sarcasm and satire, which I think. Okay, all right, and then and so the other major thing that is important to understand is the TF-IDF. Okay, this is called the term. This is the term frequency inverse document frequency matrix. Okay, and the way a term frequency inverse document frequency matrix works is that it's going to, for each document is going to kind of get its own line, and each word gets its own column, and if it were just a term frequency matrix, then it would just each line would just say how many times a particular word appears in the document. Okay, which is simple enough. Okay, but what the inverse document frequency does together is it says, you know, this word is not a common word, right? So if you had a term frequency or something, and if let's just say we did not remove stop words, okay? So words like is going to appear very frequently in all the documents, okay? Because it's just a very common word, okay? However, if you look at the inverse document frequency, it's going to say is not really an important word for any of these documents because it appears frequently in this document, it appears frequently in this document, and it appears frequently in this document. So this is not something that's really significant, not going to help us learn much about the document, okay? However, a word like Bayesian or something like that, that's only going to appear in words that are related to statistics and machine learning, and you probably won't ever see the word Bayesian in other contexts, right? You're not going to see, like, in I don't know, in just a norm, like if you look at Twitter and you run the search for Bayesian, it's not going to show up in anybody's tweets unless that person is talking about statistics or machine learning or something related, okay? And so the term Bayesian, because it only appears in certain types of documents and things like that, its inverse document frequency will get weighted a lot more, right? And so regarding, so it's not a common word, but and because it's associated only with certain types of documents or conversations, it gives you a very clear indicator of maybe the context or something like that, right? So it's kind of like, you know, if you're at a restaurant and you overhear someone mention the word Bayesian, you're going to maybe suddenly be interested and say like, oh, I heard you guys talking about this, right? Versus, so there's certain kind of keywords that, you know, only certain people or certain certain interests we'll use, whereas outside of that, probably not as frequently, right? So inverse document frequency will decrease the wait for words and increases the wait for words that are not used very much in a collection of documents. And so so that's what we have. And the term frequency, inverse document frequency, will measure how important a particular word is to a document or collection of documents. Okay, and so so this is what we have here, and you can look up more on TF-IDF on Wikipedia. There's a lot of stuff here, and it kind of gives you the formulas, but just the idea is. So here's one word. This is a sample, and this is another example. And so the example shows up, only shows up in this document, and it's going to get weighted a lot heavier for document 2 than it does document 1. Okay. Okay, so we can do this. We can do the count of the words. Okay, unnest the tokens, do the count, and then we can kind of do summarize this to get a total thing, and we'll get, for each of these words, how does all of this appear, right? Okay, so as far as the books go, it goes through and it just says, this is how often these words appear in each of these books, right? So the appears very often, and to and the appear very often in the book Emma, and things like that. Okay, so that's fine. Okay. All right, and so you have this, all of these kind of right skewed things, and so now we're going to do get a rank, okay, based on its term frequency, and there's a few, there's kind of this thing called Zipf's law that says that the frequency that a word appears is inversely proportional to its rank, and we can kind of check that, and indeed there does seem to be a relationship there between the frequency and its rank, that when we do a log scale we get almost a straight line there. Okay. Okay. So it lines up quite closely to kind of these middle things. Okay. Anyway, to get the term frequency inverse document frequency thing, there is this function called bind TF-IDF. Okay, and so the bind TF-IDF is going to help us create this term frequency inverse document frequency here. Okay, so what it does is it takes, currently we have our book words, just has each book, the word, and how many times it appears, okay, along with the total number of words in that particular book. Okay, so Emma has 160,996 words, which is coincidentally very close to the number of words in Mansfield Park. Pride and Prejudice has much fewer words. Okay, but anyway, you can do just do bind TF-IDF. Okay, and so there it's going to find the term frequency and then and it's going to multiply it by the inverse document frequency, okay? And so all of these things, words like the, to, and, all have very low inverse document frequencies, and so when you multiply the two together, you get you get practically a zero TF IDF, okay? And so here what we can do is so we'll get rid of the column total, and we'll just rank them by inverse term frequency, inverse document frequency, okay? So we're gonna rank them by this thing, the product of the TF and the IDF, okay? And what we see, okay, this should not be a huge surprise, is that the character names that are unique to these books have the greatest term frequency, inverse document frequency things, right? So in Pride and Prejudice, Mr. Darcy is, one of the main characters, and the name Darcy only appears in Pride and Prejudice. So as far as the term frequency goes, for the book Pride and Prejudice, it has a high term frequency, and as far as inverse document frequency, when you compare it to the other works, okay, it has a high inverse document frequency, okay? It doesn't appear in any of the other documents, basically, okay? The word Darcy, the name Darcy, doesn't appear in the other books, and so it has a high inverse document frequency thing, and so it gets a very high TF-IDF, right? And so if we're on the subject of Jane Austen's books, and you ever see the name Darcy, you know immediately that this is talking about Pride and Prejudice because it doesn't appear anywhere else, okay? Similarly, for the book Emma, okay, no surprise here, Emma has a very high TF-IDF value for the book Emma, okay? And so pretty much all of these things are character names, okay? And the same kind of idea here, I mean, maybe this is not as exciting, but it also just reflects how the term frequency inverse document frequency goes, is just that if a word only appears in one of the documents or a couple of the documents, it has a greater inverse document frequency, and depending on how frequently it appears in its own document will be the term frequency, right? So Pride and Prejudice is about kind of the Bennet family, Elizabeth Bennet, and Mr. Darcy, and then Sense and Sensibility. There's the characters Eleanor and Marianne and things like that. Okay, and so so that's what we get there. Okay, and so here we have the TF-IDF values for each book, and I'm just trying to see if there's anything. Yeah, I guess these are all kind of proper names. Okay, they're all proper names. But yeah, as so here they do it on they do something similar on a bunch of physics textbooks. Okay. So a discourse on floating bodies by Galileo Galilei. So he's doing astronomy stuff. A treatise on light, experiments with alternate current by Nikola Tesla, and relativity, special and general theory by Albert Einstein. Okay, and so so we can do a TF-IDF for each of these authors. Okay, and lo and behold, the TF-IDF shows us probably what we might have expected, okay? So when we're looking at Albert Einstein's books, we're looking at words that are important to Albert Einstein's that don't appear really very often in the other textbooks, are things like relativity, theory, gravitational, things like that, okay? For Nikola Tesla, words like bulb, coil, wire, discharge, and currents are very important, okay? for Christian Huygens' work on light, we have things like refraction, crystal ray, spheroid, and things for Galileo. Now we get words like water and half because it was written. He was Italian, right? I don't know who translated this, but something, right? We have just funny spellings of things, okay? So probably not the best for Galileo's work, because now we're getting artifacts of just translation from old-timey stuff. But interesting stuff. And so a lot of work can be done with kind of the term frequency, inverse document frequency stuff here, okay? And you know, we just looked at a couple of chapters from this book on tidy text mining. One thing I like about this is that it uses the tidyverse set of packages, which I'm hoping you guys are familiar with, and it allows you to kind of see how I think it's easy to kind of understand the text and the code that's being written. Okay, so there's a whole world of text analysis that can be done, and you know, if it's something that interests you, I do recommend this textbook, and you know, the other kind of package that's out there that is probably worth checking out is the TM package for R. Okay, and there's quite a bit written on it, and so you're gonna have to kind of traverse through it. But probably this first one right here, Introduction to the TM package, Text Mining in R. I think that's going to be kind of your first hit. This vignette here is a good place to start for the TM package. Okay, which is also something there. Okay. Anyway, I told the TA she doesn't have to hold a section, so we're not going to have section. And then on Monday we'll spend time in review. So go ahead and start studying the conceptual problems in the textbook. I'll work on writing the exam, and whatever questions you have, bring them on Monday, and I'm happy to answer them. And we'll see you then. Okay. All right. Have a good, I guess, weekend already. It starts now. Okay. We'll see you.